Okay, let's have a look at some quadratic equations. In this example, they want us to have a look at this equation, x squared minus 2x minus 8, and identify the following. First, zeros, and then y-intercepts, so where the function is crossing the the y-axis. Turning points, or stationary points, extreme points, there are different names, but basically if there's a minimum or if there's a maximum. And then the axis of symmetry that will go through the turning point, through the minimum or maximum, a vertical line. And then the domain, which is basically all allowed, all possible x values. And then we have to have a look at the range, which is a description of all the possible y values. And then give a range for which values of x the function is increasing, which means that it's going up, or when the function f of x is decreasing, when the function is going down. And then finally sketch the graph. So let's go through this one step at a time, and we'll do it with algebra and also with the calculator. First, we can have a look at this function, and we see that the x2 term is positive. Okay, so that means that this will be kind of smiley. It will have this kind of U shape. Okay, which means that we will have a minimum, will not have a maximum. So just because it has a positive x2 term, it's the hyperbola, it's going to look like a U shape, and it will have a minimum. So let's find the zeros. So x squared minus 2x minus 8. First, the f of x is equal to x squared minus 2x. Oops, it's a little bit difficult with this pen. Minus 8. So we can always use the general formula, and you remember that x is equal to, if we have a function that looks like this on this form, some constant a times x squared plus b x plus c. In this case, the a term is in front here. We don't really see it, but it's a 1 times x squared, but we don't write it. Since it's just a 1, it doesn't change anything. So in this case, a would be 1, b is equal to minus 2, and then c is equal to minus 8. So this is the formula. I'm not going to do it because this is actually quite easy to factorize without doing the general formula. So minus b plus minus, I'm going to write what's inside this big square root. That looks like this, b squared minus 4 times a times c, and everything divided by 2 times a. We just write 2a. Okay, so we can just put in these 3 constants and get the 2 zeros, or the 2 roots of the function. In this case, I'm going to look at the minus 8, or actually first just the 8. I'm not going to pay attention to the plus or minus sign. So 8, what possible factors do we have? Well, we have 1 times 8, for example, or 2 times 4. Both work fine. Both will get us some kind of 8, and then we just have to adjust the sign plus or minus. But with this 1 and an 8, or the 2 and a 4, we have to get this 2. And I can't really get 8 minus 1 or 1 minus 8 or something like that to get a 2. But with a 4 and a 2 as factors, I can actually get the minus 2. So if I write this here again, and I know there's going to be something like this, 2 brackets, and then since we just have a positive x2 term, no constant in front, it's going to be x here and x here, and then we thought that it would be 2 and 4, so I'm going to write 4 here and 2 here. Then the next question is, what about the sign? Well, first x times x is going to be x squared, so that will give us this, and then x times 2 is going to be 2x, and then if we take minus 4x, then we'll get plus 2x minus 4x, that will give us minus 2x, so let's try that, minus here and then plus here. How about the constant minus 8? Well, minus 4 times plus 2 is equal to minus 8. So this is this will work out. So this means basically, if we were to solve this equation, because this is what we have to do, solve when f of x, or sometimes it says y is equal to, and this expression, when this is 0. So basically when the y value is 0, for which x is this true? That's when we're crossing the x-axis, when y is 0. So either this factor or this bracket, x minus 4, has to be 2, and then it's actually times here. We don't write it out, but it's actually multiplication. So this factor x minus 4 is equal to 0, or x plus 2 is equal to 0. So in the first case, well, if x is equal to 4, we just put x is equal to 4, then we get 4 minus 4 is equal to 0. 0 times 6 is still 0, so that will give us 0. The other case would be if x is equal to, let's have a look at the second factor, the second bracket. Well, if x is minus 2, then it becomes minus 2 plus 2, which is 0, and then 0 times minus 6 is still going to be 0. So the second 0, the second root is minus 2. Okay, let's go back to the question. So the zeros, we can just write x is equal to 4 or x is equal to minus 2. The way to do it on the calculator would be, for example, like this. Let's define the function. Usually it's a good idea to name it f1, and then if you have more than one functions, the second one could be f2, the third one f3, and so on. f1 is a function of x, that's the variable, and we have to have this colon equal to, so I'm going to hit control and this to define the function, and it was x squared minus 2x minus 8. Enter. And now in the menu we have algebra, solve, and we would like to know when this function f of x, or in this case in the calculator is f1 of x, when this is equal to 0, and then we have to add comma x to tell the calculator that the variable we want you to solve this equation for is x, and then enter, and we get minus 2 or 4, which is exactly what we confirmed here. Okay, so then we move on to y-intercepts. Actually, it can be a good idea just to actually draw the graph of this function. So I'm going to add a graphs page, and then it's easier to talk about when we can look at the graph. So I'm going to go up. Here we have the function. I'm just going to press enter, and there we go. I'm going to zoom out once so I just see the turning point. I'm going to go to menu, Windows, zoom, and then zoom out, click somewhere here, and now we see the turning point. Okay, so basically we can see here that the function is crossing the x-axis at x is equal to minus 2 over here, and here where x is equal to 4. We can also confirm that with a calculator. We're going to analyze the graph. 0, since we just have one function in the window, we can start right away. Go a little bit to the left and then to the right, and here's a 0. I'm going to move the coordinates up here. The second 0, analyze graph. Oops, it's a little bit slow. 0 once again. A little bit to the left, a little bit to the right, and here we go. So actually, they asked us for identify the following zeros. Either we could answer x is equal to 4, x is equal to -2, or we can actually give them the coordinates. So it would be -2, 0, 4, 0. Of course, the y value is 0 here because it's on the x-axis, and on the x-axis the y value is 0. Let's move on to the next one, which is y-intercept. So basically we would like to know the coordinates for this point when the graph of the function is crossing, when the curve is crossing the y-axis. And we can see here in the window that it's minus 1, 2, 3, 4, 5, 6, 7, 8. And there's another way to do that, of course, by looking at the function, and you can also do it algebraically. So let's have a look at some different ways of doing it. Basically, we know that when the function is crossing when the curve of the function is crossing the y-axis, x is equal to 0. Okay, so x is going to be equal to 0. The question is, what is the y value? So if you just put in x is equal to 0 into this function, so that would be 0 squared minus 2 times 0, nothing, and then minus 8. So the y value is going to be minus 8. Algebraically, it would look something like this. Let's have a look. So y-intercept would be f of 0. Then we can write it out. So it's going to be, remember, x squared, so 0 squared minus 2 times, and I'm going to write it within bracket, this means minus 2 times 0, and then minus 8. And this is of course 0, this is of course 0, so we're left with minus 8. So the answer would be, the coordinates for the y-intercept would be, of course, x value is equal to 0, y value is equal to minus 8. And with a calculator we can do this by going back to the calculator page and just type f1, which is our function, and put in x is equal to 0, and then f1 of x is the y value, and here we have the y value. Okay, the next thing would be turning points. So basically we can say that since the x2 term is positive, it's going to be a minimum. We know that. The question is, how do we solve this algebraically? Well, we can find the zeros, and remember that the zeros are minus 2 and 4, so that means that the turning point, the minimum will be right in the middle of the two zeros. So we can just look at the graph and say x is equal to 1. How do we do this? Well, we take the zeros 4 and minus 2, 4 plus minus 2, and we divide it by 2. This is equal to 2 divided by 2 is equal to 1. That is the x value, okay? Now if we look at this, we see that x value is 1. If we don't have a calculator, how do we find the y value? Well, we just put in x is equal to 1 in our function. So f of 1, what do we get? Remember, the function is x squared, so it's going to be 1 squared minus 2x is going to be minus 2 times x, which is 1, minus 8. Let's simplify a little bit. 1 squared is equal to 1, minus 2 times 1 is equal to minus 2, minus 8. So 1 minus 2 is minus 1, minus 8 is equal to minus 9. So we can say that we have a minimum for x is equal to 1 and y is equal to minus 9. And of course, if we have a calculator and it's a calculator exercise, we just analyze the graph and we know that it's a minimum. And then since we just have one graph here, we can start right away to go a little bit to the left to the minimum that we're trying to find, and then go a little bit to the right, and then it will give us 1 and minus 9. Next step would be axis of symmetry, which is very easy because we can just, if we think of the graph, it's going to be vertical line dividing this hyperbola into two parts, to kind of, this is the mirror reflection of the other part. So it's going to go right through this turning point, the minimum. So basically we just need an equation of that line, and the equation is going to be x is equal to 1, because that describes this vertical line going through the turning point. So we are going to write, remember, axis of symmetry. Axis of symmetry, a little bit difficult to write with this pad. X is equal to 1, and that's the equation. Next step, domain. So basically we have to ask ourselves the question, what are the possible x values? Well, if we look at the function, we cannot really say that there's no x value that is not allowed. I can put in 0, I can put in any positive value, decimals, I can put in any negative value. I'm allowed to square a negative value. So this is very easy. Also, if we look at this, we know that we see that the function is defined for all these x values. For x is equal to 1, we have this point, x is equal to 2. We go down here and meet the curve, and we see that it's defined. And then for very large values, it's just going to be a value up here. It's going to grow pretty fast. Same thing for, if we go to the left on the x-axis, for negative values, we're going to go up here, but it's still defined. So the answer on the domain question, domain is going to be very simple. Just going to get some more space here, going up, so we can start a new page. Domain one way of writing it is x belongs to R, which is basically like saying all real values of x. Okay, so another way would be all real values of x. So remember, real value, you have positive, negative, you have decimals, you have numbers like pi that cannot be expressed as a fraction, etc. All real values. And the second question here about the possible values, they want to know the range. So the range is all possible y values. So if we look at the graph, now we have to have all this information, especially the turning point, because we know that the function is continuing up here to the right, and if we go to the left, also going up. So basically we know that the function is not defined below here, below, well, -9 is the lowest y value. So if it's less than -9, the function is not defined. So how can we express that with some kind of, let's see, range? So y is going to be all the real values, but we're going to add a little but. Y has to be greater than or equal to -9. So which means that equal to, it can be -9, but it can also be greater, okay? It has to be greater than -9 or equal to -9. It cannot be less than -9. So this is the way to express that. Then we have to ask ourselves, when is the function increasing, when is it decreasing? Okay, so basically we have to know the graph of the function to have a look at it, and we see that that means basically if we're walking on the x-axis and we go from left to right, so we're walking here in this direction, going to the right, is the function going up or down? Is it growing or is it decreasing? In this case, we see that this is kind of the turning point. So from this x value, when x is equal to 1, to the right of that function, the y value is going to increase, so it's growing. And then all the values to the left of x is equal to 1, the function is decreasing. Okay, so when we go here for these x values, -5, -4, -3, -2, the function is decreasing. So a way to express that would be f of x increasing for x is greater than 1. Remember, it's going up when x is greater than 1. And then it's decreasing, f of x decreasing for all x values less than 1. And then with all this information, we have the zeros, we have the coordinates for the turning point, we know there's a minimum, we have the axis of symmetry, etc. We can actually sketch the graph, so that would be the last exercise, to sketch the graph here.